Hello, in this video we're going to be having a look at sequences. We're going to start off in the first part of the video by working out the value of terms in a sequence if I've been given the nth term expression for that sequence. So we've got some linear expressions and we've got some quadratic ones down here. In the second part of the video we're going to be looking at how to calculate the nth term expression for a sequence if I've been given the sequence itself, and we're just going to concentrate on linear sequences in the second part of the video. Okay, first things first, what do I mean by this 3n plus 7? What does this n thing here stand for? Well, all n is the position of the terms within the sequence. So when n equals 1, that's going to give me the position 1, so it's going to give me the value of the first term in my sequence. N equals 2, then that's going to give me the second term, and if I substitute n equals 2 into my expression, it's going to give me the value of the second term. Let's write a few down and it should become a little bit clearer. So we've got n equals 1, 2 and 3. So the positions, my first, second and third terms in my sequence. If I substitute the value n equals 1 into my expression, it's going to give me the value of the first term. So I've got 3 times n, 3 times 1, plus 7, so 3 times 1 is 3, plus 7. The value of the first term is 10. So my first position, substitute n equals 1, I get the value 10, that's my first term in my sequence. If I've got n equals 2, substitute that into my expression, I get 3 times 2, which is 6, plus 7 equals 13. So n equals 2 gives me my second term in my sequence. The value is 13. To get the value for the third term, I need to substitute n equals 3. So 3 times 3 is 9, plus 7 is going to give me 16. So I've got my first 3 terms of my sequence by substituting in the values 1, 2 and 3. Now the question itself asked me for the 10th term in this sequence. So I'm looking for the value when n is equal to 10. So my 10th term, I've got 3 lots of 10 plus 7. Let's write that down. So we've got 3 times 10 plus 7, and that's equal to 30 plus 7, which is 37. So my 10th term, I haven't produced any values between 4 and 9, so my 10th term is going to have a value of 37. Let's have a look at the next one. So the 5th term, so I'm going to get that by substituting in the value n equals 5 into my expression 5n plus 2. So I've got 5 lots of n, I've got 5 lots of, well, n is equal to 5 as well, and I want to add 2. So 5 lots of 5 is 25 plus 2, and that's equal to 27. So my 5th term has a value of 27. Next one down, I'm looking for the 4th term, so I'm going to get that by using n equals 4 and substituting that into my expression here. This time, rather than a linear expression, we've actually got a quadratic, and I've got a value of n squared. So I'm going to substitute in my value of n is 4, and then I need to square it. So 4 squared, 4 times 4, which is equal to 16. So the value of my 4th term is 16. For my 5th term, I'm going to be substituting in n equals 5 into the expression n squared plus 1. So I've got 5 squared plus 1. Well, 5 squared I know is 25. Add my 1, and I've got a value of 26. So the value of my 5th term of this sequence is 26. Get there by substituting my value n equals 5. Last one, 3rd term, I'm going to be substituting in n equals 3 to get my value of my 3rd term. This I need to be really careful. I've got 2n squared. I'm going to have to remember my BIDMAS rules. BIDMAS, let's write it down here. So I need to do my index before my multiplication. So what have we got? We've got n is equal to 3, so I'm going to substitute those in. So I've got 2 times n is equal to 3, and I need to square it. I need to square my 3 before I multiply by my 2. So that's equal to 2 lots of 3 squared. 3 times 3 is 9. 2 times 9 is equal to 18. So the third term, the value of the third term is 18 in this sequence. Just be really careful. It's really tempting to do 2 lots of n, 2 lots of 3 is 6, square it and get 36. It's not right. We need to remember that BIDMAS rules. So I'm going to square it and then multiply by 2. So 2 lots of 9, 18, and I've got the values of the terms within my sequence. Right, what I'd like you to do next is have a go at the code breaker, which was attached to the email. So read through the email for your instructions. Once you've done that, come back to the video and watch the second part. In this second part of the video, we're going to have a look at how we can generate the nth term expression for a linear sequence. The couple of examples I've got down here, I've already got the nth term expression, but I want to have a closer look at these two sequences to see whether we can spot some trends between the two. Okay, so first things first, this one at the top, we've got 2n plus 1, and we've got the first 5 terms in the sequence. So n equals 1, 2, 3, 4, 5, my first through to my 5th position. So let's work out what these terms are. So when n is equal to 1, I've got 2 lots of 1, 2 plus 1 is 3. When n equals 2, I've got 2 lots of 2's 4 plus 1 is 5. n equals 3, I've got 2 lots of 3 is 6, plus 1 is 7. n equals 4, I've got 2 lots of 4 is 8, plus 1 is 9. n equals 5, I've got 2 lots of 5, plus 1 gives me 11. Then I want to have a look at what the differences are between each of the numbers within the sequence. So the difference between 3 and 5 is 2, between 5 and 7 is 2, 7 and 9 is 2, and 9 and 11 is also 2. Come back to that in a minute. Have a look at the second example now. We've got 4n plus 3. So when n equals 1, I've got 4 lots of 1, 4 plus 3 is 7. I've got 4 lots of 2 is 8 plus 3 is 11. I've got 4 lots of 3, 12 plus 3 is 15. I've got 4 lots of 4, which is 16, plus 3 is 19. And then I've got 4 lots of 5, which is 20, plus 3 is 23. Let's have a look at what the differences are between those values. So we've got the difference between 7 and 11, which is 4. The difference between 11 and 15, which is 4. And the difference between 15 and 19 and 23, 4 in both cases. Okay. Whenever we have a linear sequence, we're always going to find the same thing. This number here in front of my n tells me what the differences are going to be between each term in that sequence. Always going to have a difference of 2. So same with this one down here. The number in front of my n, this is a 4n sequence. So 4n, that 4 tells me that the differences in each case are going to be a 4. Right, why is that important? So next example. We've got a linear sequence. We've got our positions from 1 through to 5, but I don't know what that nth term expression is. I want to try and work out what it is. So the first thing I'm going to do is I'm going to have a look at the differences between each of those terms. So the difference between 5 and 8 is 3, 8 and 11 is 3, 11 and 14 is 3, 14 and 17 is 3. If it's a linear sequence, those differences are always going to be the same. If they're not the same, then it's not a linear sequence. So the differences are 3. So I know that this must be some sort of 3n sequence. It's not going to be 3n exactly. It's going to be 3n plus or minus something, but it's going to be a type of 3n sequence. So 3n, what would that be? So if n is equal to 1, this would be 3, 3 lots of 2 is 6, 3 lots of 3 is 9, 3 lots of 4 is 12, 3 lots of 5 is 15. So this 3n sequence is quite close to the sequence that I'm looking for, but my sequence is always, well, it's 2 higher than the 8's 2 higher than 6, 11's 2 higher than 9, 14's 2 higher than 12, 17's 2 higher than 15. So my sequence is 3n plus 2. So 3 plus 2 is 5, 6 plus 2 is 8, 9 plus 2 is 11, 12 plus 2 is 14, 15 plus 2 is 17. So my 5, 8, 11, 14, 17, the sequence that we're looking for, 3n plus 2. Let's have a look at the next one. So the difference is, they're going to be 3 again, just like the example above. So we know that we're dealing with a 3n sequence. We can write it down. So we've got 3, 6, 9, 12 and 15, just like we had in the top example. This time though, my sequence is a little bit smaller than this. So I've got 2 rather than 3, 5 rather than 6, 8 rather than 9, 11 rather than 12, 14 rather than 15. So my sequence is 3n take away 1. So 3n, if I take 1 away, I get 2, 5, 8, 11 and 14, which is the sequence that I'm looking for. Whenever you do these, it's always worth substituting in n equals 1 and 2, the first couple of values in your sequence, and check that you've got them right. So if I've got n equals 1, I've got 3 lots of 1 is 3, take away 1 is 2, it's my first term. N equals 2, I've got 3 lots of 2 is 6, take away 1 is 5, and I've got that second value in my sequence. It's really easy to write 3n plus 1 rather than 3n minus 1. If you check those two values, then you can pick up on some of those easy mistakes. I'm going to have a look at one more example. This one's a bit more tricky. This time my sequence, instead of going up being an increasing sequence, is going down, so it's a decreasing sequence. So the difference is 3, but it's actually going down. It's 3 less than the value before. So I start with 5 and I take 3 away, I get to 2. Start with 2, take 3 away, I get negative 1. Take 3 away, I get to negative 4. So my sequence this time is minus 3n. So minus 3, if n is equal to 1, that's minus 3. When n is equal to 2, minus 3 times 2, it's going to give me negative 6, negative 9, negative 12, and when n is 5, I'm going to get negative 15. So this time my sequence actually looks quite a little bit different. So my sequence is a lot higher. Well, it's 8 higher than negative 3, so that's a whole 11 values greater than negative 3. So negative 3n plus 11, so negative 3 plus 11 would give me 8, negative 6 plus 11 would give me 5, negative 9 plus 11 gives me 2, negative 12 plus 11 gives me negative 1, negative 4 plus 11, negative 15 plus 11 is going to give me negative 4. Have I got the right sequence? So 8, 5, 2, negative 1, negative 4, 8, 5, 2, negative 1, negative 4. Check those first couple of values. So if n equals 1, I've got negative 3 plus 11, that gives me my 8. When n equals 2, I've got negative 3 times 2, so negative 6 plus 11 is equal to 5. I've got those two values. So my nth term expression is minus 3n plus 11. Sometimes you might write that round the other way, 11 minus 3n. Some people don't like to write a minus sign at the front of an expression, but either of those two expressions are completely correct. They both describe the sequence that we've got here. Okay, time for you to get some practice, so have a go at the exercise that's been set for you.